Hello.
Good afternoon, sir.
Good afternoon. Okay, today we are going to start with the written part. So first question, what was there recently also? Don't go by the date what is written here in this question. Recently, I think in somewhere in July or August, they asked this again. Differentiate between squirrel cage and wound rotor motor of three-phase induction type in respect of the following. So what you have to differentiate between rotor construction, torque characteristic, and speed variation. So what is the difference between the rotor construction of these two motors? Hmm?
Rotor construction, sir.
How both the rotors are different? Okay, we'll just see. Squirrel cage motor. The rotor consists of cylindrical laminated core with parallel slot carrying the rotor conductor, which are heavy bars of copper, aluminum, or alloy. One bar placed in each slot. How it looks like? Just give me a minute. I'll open another slide and I will show you how it looks like. I hope you can see the PPT on your screen now.
Yes, sir.
So this
P-
is the construction. PPT
Sir,
only you can see, or PDF?
PDF I am seeing this, not PPT.
Not PPT. I already shared PPT. Now,
No, now I can see.
okay. So see what is the squirrel cage motor. Squirrel cage rotor consists of a set of conductive bars. Can you see this conductive bar in the diagram?
Yes, sir.
Okay, these are the conductive bars. These bars are made up of copper or aluminum. They are short circuit by the end ring. These are two end ring. This is the end ring and this is a end ring. The bar and the ring resemble the shape of the square cage, hence they are known as squirrel cage motor. What are the advantages? Squirrel cage rotor are simple in construction, robust, and require minimum maintenance due to the absence of the slip ring and brushes. They are cost effective and widely used in most general purpose application. What is the disadvantage? Squirrel cage motor have limited speed control capability. So if you are using a squirrel cage motor on board, then and you want to control the speed, then you have to put VFD, that is variable frequency different drive. You cannot do from the squirrel cage motor itself. Now we are going to see about the construction part of the wound rotor. The wound rotor consists of the slip ring. So now here you have the slip ring. Now wires are, can you see the wires are coming and connected to the slip ring and contain a set of three-phase winding that are externally connected to the slip ring. Now your slip ring is connected to the three-phase winding. The slip ring allow the external resistor or the device to be connected to the rotor. The advantage of the wound motor rotor are they have the variable speed control characteristic. How they are controlling the speed? If you are going to change the resistance here, just put a rheostat and vary the resistance, and as soon as the resistance is going to change, the speed of the motor will also change. So by varying the resistance connected to the rotor winding through the slip ring, the motor speed and torque can be controlled over a wide range, making them suitable for the application with speed control is critical, such as crane, hoist, and all these places we are using this kind of the motor. What are the disadvantages? Wound motor rotor are complex in shape, construction compared to the squirrel cage. Can you see? Construction part of this is very simple, and whereas when we are seeing at the wound rotor, it is complex as compared to squirrel cage. which lead to the high manufacturing cost and increased maintenance requirement due to the presence of slip ring and the brushes. So this is the summary. Squirrel cage motor are simpler, cost effective, and require less maintenance, making them suitable for the purpose application fixed with fixed speed requirements. So wherever there is no need of varying the speed, obviously you are going to put the squirrel cage motor. On the other hand, the wound rotor motor offer the advantage of variable speed control and are preferred for application where the precise speed control and adjustable torque are essential. The choice between the squirrel cage and the wound rotor motor depend upon the specific need and operating condition of application. Clear? What is the construction difference?
Yes, sir.
Okay. Now we will go back to the PDF. Just confirm me if you can see PDF on your screen. I hope you can see the PDF.
No, sir.
Maybe there is some lag.
And now I can see this.
Okay.
Okay.
So this is the difference between squirrel cage and wood rotor. We are going to read again. The rotor consists of cylindrical laminated core with parallel slot carrying the rotor conductor, and each are heavy bar, copper, aluminum, or alloy. Same thing. The rotor bar are braced or welded electrically to the heavy and stored short circuit and ring. The rotor bar are permanently short circuited on themselves, and hence no external resistance can be added in series with the rotor for the starting purpose. Whereas when we talk about the wound rotor, this type of rotor is provided with three-phase double layer distributed winding consisting of coils. The rotor is wound for as many as number of starter pole. Three-phase are started internally, and the other three winding are brought out. So three-phase, they are start connected internally. Internally, they will be start connected, but the other end of the wire will be brought out and connected to the insulated slip ring mounting on the shaft with the brush resting on them. These brushes are further externally connected to three-phase, connected with a rheostat. This makes the possible introduction of additional resistance in the rotor circuit during the starting period and increasing the starting torque of the motor. Clear this much? So this was the first part, that is your construction part. Now second part is what? Torque characteristic. What is the difference between torque characteristic? You can draw this diagram. This is don't draw the parallel line. Draw the line like this, little bit like this. Okay, understood?
Yes, sir.
Diagrams are very important. Okay, just note down this diagram. Are you noting down, or you are just taking some screenshot and all?
Sir, I'm taking screenshot.
Okay,
Later
okay,
once
okay,
I'll make them.
okay, no problem. So next is torque characteristic. So if you are going to draw the torque characteristic for squirrel cage motor, this is the torque, this is the speed. So initially you can see the torque is very less, and slowly it's increasing and then going to the maximum. Whereas when you see the torque characteristic of the wound rotor, the starting torque increasing from the initially only. Now you are reaching the maximum torque earlier than before. So this is the difference between a torque characteristic. You have to draw these two diagrams. Doesn't matter what you are writing inside, because diagram explain it all. Anyway, we are going to see what actually it means. So this is for squirrel cage. So squirrel cage, the can you vary the resistance? In squirrel cage motor, can you vary the resistance?
The resistance are fixed.
Fixed resistance, very good. So what is going to happen? The resistance is fixed and small as compared to the reactance, which is very large, especially at the starting because it is at standstill. The frequency of the rotor current equal to the supply frequency, hence the starting current Ig of the rotor very large, and a magnitude lags by a very large angle behind the E2, with the result that the starting torque per ampere is very poor. It is roughly 15 times of the full load torque, although the starting current is 5 to 7 times of the full load current. Hence, the motor are not used where the motor has to start against the heavy load. So you are not going to use this motor. Now we are going to look for the wound rotor. The starting torque of such motor is increased by improving the power factor by adding external resistance. In this, you can add the external resistance in the rotor circuit. From the star connected rheostat, the rheostat resistance being progressively cut out as the motor gathers speed. Addition to the external resistance, however, the increase in the rotor impedance and reduce the rotor current. So at the first effect, improved power factor predominates the current, that is decreasing the effect of impedance. Hence, the starting torque is increased. But after a certain point, the effect of the increased impedance predominates the effect of the improved power factor, and so the torque start decreasing after some time. Clear?
Yes, sir.
Okay. Next is speed variation. So now on the y-axis you have the speed, on the x-axis you have the torque. Okay. So for squirrel cage motor, the speed is at starting it is maximum, and then slowly it is reducing. And this is the speed graph for the wound rotor. So what they are saying, speed falls like slightly from no load to full load. So your how much is drop in the speed? If your motor is running at no load, the speed is maximum. But if you are going to run at the full load, the speed will be reduced by 3 to 4%. And this slip is known as ns minus n divided by s multiplied by 100. Whereas when we talk about this kind of the motor, there is no slip. Starting current is high and quickly falls as the motor accelerate to the full load current. So this is the graph here you have between the current and the speed. So as soon as your motor is starting, the current is high, but when it is increasing a speed, it is decreasing. Squirrel cage are cheaper and more robust, have slightly higher efficiency and power factor, are explosion proof since there are less risk of sparking is eliminated by the absence of slip ring and the brushes. Whereas when we talk about the wound rotor, they have much higher starting torque, have a much lower starting current, hence of varying speed by using the external resistance. Okay, now this is the second question. The direct online starter of squirrel cage motor is used for most of the electrical drive in AC powered ship. Describe with the sketch as necessary one method of overcoming each of the following. So what you want to overcome? High starting current, because if you are using your squirrel cage motor in dual system, your starting current will be high. Obviously, what we are using for reducing the starting current?
Star delta starter.
Star delta auto transformer, all those things. And second is low starting torque. How you are going to overcome? So first of all, draw the graph between the speed and the torque, current. So in the first you can see current is very high, and then slowly it is reducing. And for the torque is increasing slowly. In the starting it is very low. So first problem is high starting current. This one we are going to address. Three set of the starter winding have end connection which are brought out to the starter box. So what is there in the starter box? Three windings. Changeover contact in the starter enable the 6 end. So if you are seeing only 3 winding, not the 6 end, that means your motor is, you can only connect in star. So if there are 6 end, you can connect this motor in star and delta. So three set of the stator winding have end connection which are brought out to the starter box. Changeover contact in the star enable the 6 end of the star connected for starting, and then as the rotor comes up to the speed, then the reconnected in the delta. Star connection has the effect of reducing the voltage per phase to √3 times, right? So that is 57.7% of the line voltage. Starting current and torque are only have a 1/3 of what they should be in the DOL. And star delta starter can only be used for motor with light starting load. Automatic switching to delta running condition is preferred than the manual changeover, which may be made too soon or too slowly, therefore causing the current surge. In delta running condition, V phase V is equal to V line, and the motor behave as a straightforward squirrel cage type. Built-in interlock or double throw switches prevent the star delta contact from being close together. The starter is also designed so that the star connects to have to be made before it is possible to change over to run in delta. So when you will say your motor is star connected,
Six terminal is showing
so
instead of
suppose
three.
these are the 6 terminal. These are the 6 terminal. Okay. So if these 3 terminal are short circuit and R, Y and B are connected, then this is a star connected. Okay. And when
Yes,
they
sir.
will be delta connected, if end of
Six
this one
terminal
is
one.
connected like this, then they will be delta connected, right? Yes.
Yes, sir.
Now look at this diagram. So these are the, just give me a moment. Yeah, now it's on one screen. So these are the main line coming from your, coming from
Coming was a bus bar.
from the bus bar. These are the main contacts. Okay. Now these are the phase coming from your motor, and 3 terminal are directly connected to the bus, right? And 3 terminal are short circuited. So initially when you are going to start this motor, this terminal is going to close. So it will start in star connection. Then it will change over to delta. That I will show later on how it is going to change over to delta when we are going to do star delta. Okay. This much is clear. Star connection is clear.
Yes, sir.
Okay. So in star connection, your line voltage is √3 times of phase voltage, and line current is equal to phase current. Whereas in delta, your is written wrong. Line voltage is equal to what? √3, right? Of the phase voltage. Yeah, it's written correctly. In delta, current is going to lower. Yeah. So now when we talk about the second problem, what was the second problem? Low starting torque, right? So this is star connected stator, this is star connected rotor, and you have the slip rings, and it is connected to the external resistance. Starting torque of simple squirrel cage motor is low in relation to the maximum possible operating torque. Starting torque can be increased by increasing the resistance of the rotor conductor. However, high resistance in current path result in high starting torque, but poor performance at speed unless the resistance can be reduced. As the speed builds up, induction motor with wound rotor and double squirrel cage rotor are designed to start on load with the resistance, but to run at normal speed with the resistance removed from the compensated for. So if you can add resistance like it was there in your wound motor, then you can increase, you can eliminate the problem of the low starting torque. So this is double squirrel cage motor. You can use, instead of the squirrel cage motor, what you can use, you can double squirrel cage motor you can use. What we have, this is the outer cage. Outer cage has a small area but high resistance. Inner cage has the bigger area but low resistance. Most of the current flow through the inner casing. Wastage power is less, and the flux concentration is more at the center. Double squirrel cage motor, on the other hand, of obtaining high torque for starting on load, required the motion to be fitted with the double cage rotor. The inner bar are large cross section and low resistance copper bar, but bars in the outer cage are of small size and high specific resistance. The direct online method is used for starting. Three-phase supply to the starter produce a high rotating magnetic field which cut the both set of the conductor bar. Thus, the characteristic of the both high and low resistance case combine to give the good starting and running torque. So by this, you can use the double case motor. Okay. No need to write about the wound rotor. Only one is enough. And you can draw this diagram. There was a torque. This is the torque for because of your inner case. This is the torque because of your outer case. And the total torque will be much higher than the earlier. Draw this diagram. This one. Okay.
Okay, sir.
Next is, what are the cause of overheating of induction motor? What preventive measure? So what can be the cause for overheating?
The long starting time, overload,
Overload.
condition.
Okay. So what prevent the measure are provided against the damage to the induction motor in installed condition? What are the preventive they are providing so that your motor will not overheat? There are various strips, right? What is the purpose of fuse backup protection provided to an induction motor? Why fuse backup protection is provided in the induction motor? Next question is, how does an induction motor develop torque? Basically, how it starts. Next part is, what is the condition to be satisfied for achieving maximum running torque in an induction motor? So what are the cause of overheating? Improper voltage. Motor has inadequate torque to drive the load. Motor take too long time to start. Overload. Same thing you told, right? Too low time to start and overload. Or instantaneous trip condition. If there are vibration, there is a bearing problem, or frequent start stop at short interval. Environmental condition, insulation of the starter winding breakdown, or there can be single phasing. Okay, these all can be the problem. So next they are asking what preventive measures are provided against the damage to an induction motor in installed condition. So how we are saving our motor from damage when they are installed? So heaters are provided in the stator winding to prevent any condensation taking place in the winding, which can lead to the insulation breakdown. Thus, on starting, single phasing may occur and winding will get damaged and finally burnt out. Clear? These two are clear?
Yeah.
What is the next part? What is the purpose of fuse backup protection provided to an induction motor? Fuse backup protection, if a short circuit occur in the motor, starter or supply cable, then a huge fault current will flow. If the contactor try to open under short circuit conditions, serious arcing will occur at the contacts such that it may fail to interrupt the fault current. The prolonged short circuit current will cause the serious damage to the motor starter and cable with the attendant risk of the electrical fire. To prevent this, a set of fuses or a short circuit breaker is fitted in the upstream of the contactor, which will trip out almost instantaneously, thereby protecting the contactor during the short circuit fault. So these are the various graphs. If your motor current is increasing, this is the overcurrent load tripping time. Your overcurrent load will take this much time to trip, and this is the tripping time for your fuse. Okay.
Okay, sir.
So it is important that the tripping characteristic as shown in the figure of the OCR and fuse and the circuit breaker. This is the tripping time for circuit breaker. This is the tripping time for OCR, and this is the tripping time for fuse. Are coordinated so that the contactor trip on thermal current while the fuse and circuit breaker interrupt the short circuit current. So your OCR is given for thermal current, thermal overcurrent, and whereas fuse and circuit breaker are provided for the short circuit current. This contactor fuse arrangement is usually called as backup protection. Motor fuse are choose for their I inverse current time characteristic. We are choosing the fuses on the basis of their inverse current time characteristic. Fuse used for backup protection for motor circuit have a special time current characteristic. They are generally carry steady state current well below their rated capacity to allow for the short duration. Dual starting current without any blowing. Constantly, they do not protect against the normal overload but do protect the motor and the supply system against the short circuit fault. Typically, we are designated the fuse as per this 32M63. What does 32 indicates? It indicates the continuous rating of 32 amperes. 63 indicates but a rating of 63 for starting period. So same fuse will not blow at 63 in the starting period, and M is the fuse rating. Okay. Next part is, how does an induction motor develop torque? So this is the process of developing the torque in the induction motor. First, we will look at the diagram. These are the three-phase supplies coming. You have the stator, phase winding, then you have the rotator rotating flux. What we have here, this is the rotating stator flux and twisting force. And torque is equal to F into radius on the rotor bar. And forces are acting on the shaft. This is the magnetic field generated, and it is generating the torque on the shaft. Okay, we'll go and see how. When three-phase starter winding are fed with the three-phase supply, so this is the three-phase starter winding, and you are supplying the three-phase R, Y, and B. A magnetic flux of constant magnitude but rotating at synchronizing speed is set up. So what you will generate? You will generate a magnetic flux. This flux pass through the air gap and sweep past the rotor surface, and so cut the rotor conductors, which as yet are stationary. Due to the relative speed between the rotor flux and the starting conductor, an EMF is induced in the conductor according to Faraday law of electromagnetic induction. The frequency of the induced EMF is same as the supply frequency. Its magnitude is proportional to the relative velocity between the flux and the conductor, and its direction is given by Fleming right hand rule. So you have to highlight these two parts in your answer. What one is Fleming law of electromagnetic induction, then other one what you are going to highlight is Fleming right hand rule. Since the rotor bar or conductor form a closed circuit, rotor current is produced whose direction is given by the Lenz law. Is such that it will oppose the very cause of producing it. In this case, the cause which produces the rotor current is the relative speed between rotating flux of the stator and stationary rotor conductor. Hence, to reduce the rotating speed, the rotor starts running in the same direction as the flux and tries to catch up with the rotating flux. Condition for achieving maximum running torque will be T synchronizing will be K upon R2 plus R2 square plus X square. Even if you are not going to write all this formula, then it's okay, no problem. Starting torque is maximized when the rotor resistance is equal to the rotor reactance. Torque is very sensitive to any changes in supply voltage. A change of 5% on supply voltage will produce a change of approximately 10% in the rotor torque. This is important in start delta and auto transformer. The torque of the rotor under running condition is this much. The torque under running condition is maximum at value of the slip, which make the rotor reactance per phase equal to the rotor resistance per phase. The maximum torque is independent of the rotor resistance. The speed or the slip at which the maximum torque occur determined by the rotor resistance. The torque become maximum when the rotor reactance is equal to resistance. Hence, varying the rotor resistance possible only with the slip ring motor. Maximum torque can be made to occur at any desired slip. Maximum torque vary inversely with the standstill reactance, and hence it should be kept as small as possible. Clear?
Yes, sir.
I have written a lot of things. If you are going to write 50% of what is written in this, that will be more than sufficient. Okay. I am writing extra so that even if you are going to remember 50%, then still it is going to be fine. Next is, what is soft starting of induction motor? Describe with a circuit using the thyristor used for soft starting. Discuss the advantage and disadvantage. So this is the circuit you have to draw. These are the thyristor. Then here there are gate control circuit. These are the three phases supply coming. Three phase is getting connected to the three phase of the motor. AC voltage control by delayed switching on both half cycle. Supply voltage to the starter is like this. And thyristor, when your thyristor is conducting, the cycle is becoming like this. This is a block diagram for the soft starter. Now this is the description. Soft starting is a method of supplying gradually increasing AC voltage. So earlier, can you see here, we are giving directly this voltage, but now you are giving only this much voltage in initially, the dark portion. Can you see? So you are increasing the voltage gradually. During the starting, generally referred to the efficient electronic switching technique. The main purpose of the soft starter is to facilitate the smooth start with the soft starter, with motor started up gradually and gently. The starting current are reduced and current spike are eliminated. This is the description for the soft starter. A soft starter consists of a number of anti-parallel thyristors in two in each phase. These thyristors are semiconductor component which normally are isolating, but by sending a firing signal, they can start to conduct, allow the voltage and current to pass through. When performing a soft start, a firing signal is sent to the thyristor so that only the last part of each half period of the voltage since the curve pass through. Then during the start, the firing signal is sent earlier and allowing the bigger part of the voltage to pass through the thyristor. Eventually, the firing signal is sent exactly after passing the zero, allowing 100% of the voltage to pass through. By allowing more and more of the voltage to pass through, the thyristor, this can be seen ramping up of the voltage from smoothing from something called the initial voltage to the full voltage. When performing the soft stop, opposite happens, and since the voltage of the motor is reduced during the start, both current and the torque will be decreased. In fact, if the voltage is decreased to 50% of the full load voltage, the current will be decreased to 50% also of maximum current at that speed, and the torque will be decreased to about 25% of the maximum torque. What are the advantages of soft starter? Torque is reduced, which will decrease the mechanical stress of the equipment. Less mechanical stress means reduce need of service and maintenance, longer life of equipment. With torque control, we get the best soft starting and soft stopping available today. it becomes a voltage controller over the motor operating load range. This controller monitors the motor power factor, which is a measure of motor loading. On light load, full voltage and power factor is low. So the controller reduces the motor voltage, which reduces the current while improving the power factor and efficiency. And what are the disadvantages? The replacement of whole PCB in the event of failure, because we can't, this is working on the PCB. So we can't do any maintenance on board on this kind of the starter. So that is the disadvantage. Clear?
Yes, sir.
Okay, this is the last question we are going for today. And the question is, explain the effect of reduced voltage on standard spiral cage motor with respect to of the following: burnout, starting current, starting torque, and speed. Just give me a moment. I'll just get some water for me. Yes, Kaushik, there. Okay. So burnout. First is burnout. During normal running of the squirrel cage induction, if the applied voltage is reduced, then to sustain the load, that is same power, the motor will draw more current from the supply. And the starter winding temperature will increase. Due to this, high current will be flowing through the motor as the power is equal to VI. So if V is reducing, I will be increasing. That means there will be temperature increase. As a result of this high current following through the starter winding, it may lead to burnout of the starter winding. Second part is starting current. The starting current of the induction motor depend upon the value of the supply voltage and standstill impedance of the stator winding. The presence of air gap between the starter and the rotor of induction motor increase with the reactance of the stator magnetic circuit. At startup, the squirrel cage rotor has torque reactance because frequency of its induced current in the is the highest, that is equal to the starter supply frequency. Due to these factors, the starting current drawn by the motor has a very large magnetizing component but a very small in phase component. Next part is starting torque. We know the formula for the standstill torque is how much? K1 E square R square divided by R square plus X square. And A2 will be equal to the supply voltage. And this is, and K3, this Ka or K3, whatever, this is a constant. So torque is directly proportional to what? From this expression? Voltage, right? Because all our other things are constant. R is your resistance, reactance, everything is constant. Thus, the torque is sensitive to any change in supply voltage. That is, if the voltage supply decrease, then the torque also decrease. Starting current is maximum when the rotor resistance equal to the rotor reactance. The run-up time depend upon the starting torque developed and the load on the motor. Next is the speed. So this side you have the torque, here you have the speed. So initially the torque is less, then it's more, then it's slowly going down and then increasing to maximum, then coming down. How? Because initially you have the load also more, load is going down, and if you are increasing the load, the torque will also increase. With reduction of the voltage, the motor draw the more current from the supply to sustain the load almost to the same speed. So if you want to maintain the same speed and you are decreasing the voltage, then it will take more current. However, with the considerable reduction of the voltage, the speed of the motor drop. So if you are dropping the voltage, the speed is also going to be drop. When the developed torque is unable to sustain the load torque, if the speed drops to such a level that it crosses the maximum torque point, then the motor falls back to very low speed and stop. Clear?
Yes, sir.
This is going to be our next question. Sketch and describe the method of speed control of synchronous motor by variable frequency. State the advantage and method over the other method of speed control. This we are going to do tomorrow. I think 5 questions is enough for one day because you need to revise them also, right?
Yes, sir.
So
Okay, sir.
because it is going to be overburden on you. When is the exam?
Sir, this month I have no electrical exam.
Ah,
I will appear this exam for next month. So this month my safety exam,
okay.
safety written and
Then
safety
we
oral.
have the time. I thought you are having exam on maybe next week.
No,
That
sir.
is why I was worried.
Because
Then
then
we have time, no problem.
other subject, for the other subject except this naval and electrical, we can
Hmm.
write something. But
Hmm.
for this part, we have to do this numerical exactly. For that's why I'm taking this time to sub.
Yeah, very good, very good.
Okay, sir.
Okay, thanks for your time.
Thank you, sir.